Assalamualaikum to our lecturer and everyone. My name is Nur Khairunisa binti Abdullah, and together with my project partner, Anis Rada binti Nur Rizam, will present to you about the production of hydrazine. In this video, me and Anis will present to you about the introduction, hydrazine supply and demand, the environmental issue related with its production, and finally, its process design. The introduction of hydrazine with chemical formula of N2H4 is an inorganic compound which has a pungent smell and it is a powerful reducing agent which is highly explosive. In some findings, hydrazine is said to be produced naturally by some microorganisms such as yeast, bacteria and fungi as it is an intermediate in the anaerobic oxidation of ammonia. Even though it can be found naturally, in this presentation we will focus more on its synthesis by using chemical reaction. Hydrazine reacts with acids and some metallic salts and the products are used in the manufacture of certain explosives and agricultural fungicides. Besides, hydrazine reacts with inorganic compounds to form alkyl hydrazine used as fuel in rocket and jet propulsion. Other reactions with organic compounds yield hydrazoles with hydroxides which are used in such pharmaceuticals as isoniazid in the treatment of tuberculosis and as chemical intermediates in the production of polymers and photographic chemicals. This is the graph of supply versus demand of hydrazine. Since the proposed plant is estimated to finish its construction by 2026, the market analysis has been based on that year. According to Cowboy Channel 2021, the global demand of hydrazine is approximately 90,000 tons, while production capacity is about 202,405 tons in 2016. Taking the operational hour of plants as 345 days per year, and in that 1 year, 20 days will be exclusively allocated for maintenance as to keep the plant functioning effectively. Therefore, the plant capacity is estimated to be 896 kg per hour, which will be generated by the plant to make up for the deficient, whereby the demand exceeds the supply. The plant will operate in continuous process since the capacity of the plant exceeds 5,000 metric tons per year. For marketability of hydrazine over the projection period, Europe is expected to be a prominent regional market for hydrazine manufacturing. In Europe, Germany leads the way in hydrazine production, followed by United Kingdom, France, and Italy. Hydrazine demand is predicted to increase in Europe due to the growing of pharmaceutical and water treatment industries, which would boost the hydrazine market growth throughout the forecast period. The increasing use of hydrazine as a precursor to gluing agent in the polymer sector is expected to drive hydrazine market growth in Asia Pacific and North America.
For environmental issues, the byproduct obtained from Olin-Rashid process are water and sodium chloride in the form of salt and some excess nitrogen plus ammonia as waste. We need to make sure that they are disposed of in the right manner. When waste is disposed of or recycled in a safe, ethical and responsible manner, it helps reduce the negative impact of the environment. Ensuring that waste management procedures are carried out with regularity helps ensure that fewer waste materials go to the general waste stream. In turn, this also helps reduce different forms of pollution. So, as for water, since there might be excess hydrazine after the isotropic column, a method of filtering that uses a bed of activation carbon to remove contaminants and impurities using chemical evaporation is used. Next, for sodium chloride, it is safe for sink or trash disposal, since a very small percentage of sodium chloride are unregulated and safe to pour into sink or place in the trash. Finally, for the waste in this production, which is nitrogen plus ammonia, the component will be sent to scrubbing tower to be treated before disposal.
The chemical reaction routes of hydrazine production, there are 5 possible routes which are Raschig process, Olin-Raschig process, Hofmann process, Bayer-Catazine process, and peroxide process. However, Olin-Raschig process is chosen since it is convenient and easy to be handled. The process also produces high amount of hydrazine which is good for economic aspects. Olin-Raschig process produce anhydrous hydrazine from sodium hypochlorite and ammonia. This approach is based on the chloramine-ammonia reaction in order to create the nitrogen-nitrogen single bond as well as the hydrogen chloride byproduct. There is also a side reaction occur with chloramine, which is the most significant adverse reaction. The catalyst used in this reaction is copper 2 ion. Gelatin is added to this process to scavenge metal ions and suppress the side reaction occur. According to Springer et al. 1981, the conversion and yield of hydrazine by using Olin-Rashid process are 75 and 65% respectively. Whereas for selectivity, according to Academic Cook 2018, the selectivity of hydrazine by using copper 2 ion in Olin-Rashid process was reported to be 67%.
The main reaction involved in production of hydrazine are divided into three main stages, which is oxidation of ammonia to chloramine. Chloramine then react further to produce hydrazine hydrate and then dehydration of hydrazine hydrate with aniline. The first step for this process is to obtain sodium hypochlorite. Chlorine is added to the chlorination reactor and mixed with sodium hydroxide with cooling in a molar ratio of 1:2. The solution is then being diluted by adding a water and react with an aqueous ammonia solution 15% at the temperature around 0 degrees Celsius. This process will form chloramine and sodium hydroxide. After that, the outlet stream will enter hydrazine reactor. The alkaline chloramine solution is then reacted at the temperature of 130 degrees Celsius under pressure with a 20 to 30-fold molar excess of anhydrous ammonia. The outlet stream of this process is hydrazine, sodium chloride, water, and excess ammonia. The waste in this process, which is nitrogen and ammonia, will be sent to scrubbing tower to be treated before disposed. Then the reaction mixture will enter ammonia recovery column. The excess ammonia in the outlet stream will then be separated from the reaction mixture and is recycled back into the ammonia storage tank. Next, the mixture is heated and then enters crystallizing evaporator. The purpose of this process is to remove the salt, which is sodium chloride. Sodium chloride is filtered first before being disposed. The outlet stream of crystallizing evaporator will then enter hydrate column, where hydrazine hydrate is produced. Hydrazine hydrate will enter azeotrope column to undergo dehydration process where water is removed by using aniline as a training agent. The top product of this column is aniline and water. Water is then removed by using decanter and aniline is being recycled back into the column as reflux. The bottom product of this column, which is a mixture of aniline and hydrazine, will enter hydrazine column and substantially hydrazine is produced at the top stream of the column, leaving aniline at the bottom stream, which are being recycled back into the azeotrope column.
For conclusion, hydrazine is a colorless liquid which has the chemical formula N2H4 and is an inorganic substance. It is extensively used in rockets for space missions and also used in the aerospace industry on large scale. Besides, hydrazine is being utilized in applications across water treatment, agrochemicals, blowing agents, pharmaceutical, and etc. The plant capacity of hydrazine is 896 kg per hour, which makes it suitable for continuous process. In the production of hydrazine, the wastes which have been eliminated from the process are sodium chloride, water, nitrogen, and ammonia. The possible chemical reaction rates that we have chosen is Olin-Rashid process. This approach is based on the chloramine-ammonia reaction in order to create the nitrogen-nitrogen single bond as well as the hydrogen chloride byproduct. The conversion, yield, and selectivity of the reactions are 75, 65, and 67% respectively.
This is the list of reference that we use for this project. That's all from us. Thank you.